3 in the course. Uh, this week I'm doing something a little different. I've noticed that WebEx doesn't necessarily do terribly great recording, so I'm trying recording it locally at the same time that I'm recording the WebEx meeting, primarily because I've noticed some really poor performance on the part of WebEx. Could be my internet. Maybe, maybe it's maybe it's WebEx. So regardless, I will be doing that. That's why my picture looks a little weird there, right? And I'll go ahead and minimize that because we don't need to see me more than once. Moving on, the focus of Module 3 is on databases in general and SQL-like uh, interactions. So I thought I would talk a little bit about a particular type of database called Cosmos DB. So what is it? Good question to start with. It started out as DocumentDB inside of the Azure stack. It's a scalable, durable, high performance, geographically distributed database. Mouthful, right? It gets more complicated because it's a multi-model database as well. So it supports multiple interfaces, and in particular, it supports interfaces such as document/SQL. So the old DocumentDB sort of interface where it was very much about being a document database. Also supports a graph interface, such as using a query language like Gremlin. Graph databases are mathematical graphs that are stored, that store nodes and edges with attributes associated with each one. So the idea is that you represent your problem or your data using nodes and edges, especially if there's relationships. A perfect example of that sort of thing would be pages in the internet, and the arcs between those. So the pages would be the nodes, the arcs would be the links, and potentially a weight associated with the arc based upon how much traffic goes from one link to the other. Generally speaking, those arcs are directional as well. So it's a directed acyclic graph, typically speaking. So there could be cycles, however. So I guess it's just a directed graph. Um, and another interface is a table store, so very much like a table in a tabular sort of fashion. And also it can look like to APIs, Cassandra and MongoDB. So it is essentially aimed at handling most of the types of data that are NoSQL databases. So it's a generic NoSQL sort of infrastructure that supports multiple interfaces, handling the most common types of data that's stored. So why would you use it? So one of the key pieces to it is that it is a managed service. You don't have to worry about keeping it up and running. That happens as part of what you pay for. And that is something to keep in mind, is that payment is non-trivial. uh, Cosmos can be pretty expensive and get there pretty quick. So you definitely want to keep that in mind, is that it is not your bargain basement service. However, it is really impressive, especially whenever you talk about the times of associating or of synchronizing across geographically distributed instances. It is very high performance, as in measured in milliseconds, to synchronize globally. So a very powerful sort of capability as well. It can be difficult to maintain, but it's less so whenever they're being managed for you. Eventually, you'll be able to interface with or interact with the data that's stored in one format via a different API. That doesn't exist today, at least last time I checked it didn't. So you might have data that's stored as essentially a document that you interact with as a graph. That will be coming eventually, but it hasn't happened yet. It is essentially a turnkey global distribution system with low latency, high throughput, and horizontal scaling. So a very compelling thing from a database perspective. So why are we talking about this in a big data course? Well, guess what? This is what big data is. One variation of it is big data stored in NoSQL databases, and this is a horizontally scalable big data database. So if you go through the process of creating one, it's very similar to the other resources we create. I do not recommend you creating one. And in fact, please don't, because it will get me in all kinds of trouble, because as I said, they're not cheap. But you go through the process of searching for Azure Cosmos DB. When you find it, you click on Create. You fill in the typical stuff we always fill in, which is what resource group it's going to go into, the name of the account, and you have to pick an API at the time of creation. And you can see here that your choices are either Azure Cosmos DB for Mongo, Cassandra, or Azure Table, or Gremlin, which is the graph. Generally speaking, most people are probably going to be creating it as an SQL interface, so the new kind of document sort of interface. You specify several things along the way as far as what sort of capacity model you're looking for, if this is going to be for a free tier sort of discount, so if you're going to be using it for experimentation or development, or if you're actually going to be using it in production, and if it's a production database versus not, and all this kind of goes into the cost. So there are, the idea here is to pick what is appropriate for what you're doing, including things like the multi-region rights and availability zones. Once you go through the process of creating it, you filling in all that stuff, you go through the validation. It tells you roughly what it might cost you. In some ways, it's a little challenging because it is very much about the number of reads and writes that impact your cost. You validate it, and then you do the creation, and it goes through the process of doing the deployment. Once it gets deployed, then you're asking, well, how do I use it? And that's where the homepage that you land on after deployment kind of walks you through a lot of that. There's several ways you can do it, including things like containers, or you can create a default container inside of it for experimentation, and there's also the ability to interact with a notebook sort of interface. Microsoft was smart, and they saw that notebooks are cool, and Jupyter Notebooks was really pretty compelling, and it's kind of changing the way a lot of workloads are being done. So they started embracing that and introducing their own sort of notebooks so that you can create notebooks yourself. And for example, here is one of those notebooks. And what it does is goes through and lets you kind of work through the process, getting started, getting used to it using the .NET SDK for SQL, right? So it's basically the document-oriented approach, using that through the .NET SDK to interact with it. And you do so by going and getting several packages and installing them and so on. But it's basically kind of a hello world, or get started. The basic architecture that you do is very much about this sort of pattern. You create a client, giving it an endpoint and a key, and you do have, that's kind of the authentication mechanism, is endpoints and keys. And then you basically create, if it doesn't exist, a particular database of interest. And that does what the name implies. And async at the end means that it's basically going to be an asynchronous operation that you're going to wait to complete using that await command inside of C#. And then within a given database, you have containers. And so the next thing is to, if it doesn't exist, go ahead and create a container. And the second thing there is the VIN. That's essentially the partition key. So how are you going to separate the various items? And this kind of deals with sharding and distributed databases, a topic for another day, but that's kind of the purpose of it. And then the next thing is to display basically that markdown at the bottom, which is showing you pretty much that it is what we're doing here is creating it with vehicle telemetry data and that contains sensor information. And then the mapping, and this is part of the thing that makes NoSQL databases very compelling, is that you identify a structure that is of interest, which in this case is that struct that you see where there is a field called ID, VIN, event name, vehicle type, fuel type, S1, S2, S3, a timestamp, a date, and then a region. And then that gets essentially serialized into a JSON document that is then going to be used to insert into the database. And that gets, under the covers, transferred into JSON for you. And that JSON document is what's actually being stored. And you see there's an attribute there called VIN that is essentially the key, if you will. So I'm trying to turn on my pointer so I can point at VIN. So you can see there that that is essentially the key for that particular document that's being stored inside of that document database. So your document is literally a set of JSON documents that are being stored. You can see over here that there's an array of them. We're looking at one of them, but there's more after down here where the comma is, and so on. And so at a very high level, that's essentially what a NoSQL database looks like. Maybe not as compelling and as exciting as some, but it is still quite useful. The reason that I kind of went through that was, well, one, I was going to talk about APA, and I'll post one or two recordings that I've created already tonight that centers on APA. And so I didn't really want to go through all that again because there's not a whole lot of difference. I wanted to have the live classroom so that we have the choice of opportunity to speak if you were to join. No expectation that you have to, because the point of these sort of courses is that they are intended to also be asynchronous in nature. So I did want to, though, introduce some additional topics, such as things like NoSQL databases and the use of query type operations on top of those sort of constructs. And with that, I've kind of finished what I have to say about Cosmos DB. The key thing to take away, it is a interesting architecture that utilizes multiple interfaces to the same data store that can be pretty much unbounded in size. And so that's a key concept to understand, is that it's not necessarily something that needs to be small. And also it is compelling because you can query it in an SQL sort of way, and it's not a relational database, and it is a big data database in every sense of the word. So that's the primary reason I wanted to talk about it. As always, if you have questions about any of this material, comments, commentaries, if you want to hear something else, let me know. That's what I'm here for. I will be posting this recording as well as the WebEx recording, because I have noticed they're sketchy at best, and I'll be posting both of those fairly soon. If you have any questions, let me know. Stay safe, and we'll speak again soon.